In this video, we are going to model ozone depletion. Here is a list of the supplies you will need to carry out this exercise. The laminator option is really only if you're a teacher instead of a student watching this and if you want to make a class set. In terms of the writing utensil, though, I will mention I used a pencil as well as a box of markers. Next, out of the 5 different colored sheets of construction paper, take one, and with that one, using something like a pencil and a round circular object, I used a small plastic cup. I want you to trace out 3 different circles. And then after you finish tracing them out, you're going to cut them out. And after you finish cutting them out, you're going to label each of them with an O, and O stands for oxygen. Now, if you're a teacher instead of a student, you might want to actually label both sides. So if you laminate these later, then you can, it wouldn't matter which side a person was looking at. But if you're just a student completing this exercise, then obviously you'll just make sure you always, when we model this, use the labeled side up. Next, I want you to repeat this process of tracing and cutting out 3 more circles, but this time label the circles with Cl, and Cl represents chlorine. Now, if you notice, I happen to use markers of different colors for the different atoms. That's totally up to you. And the reality is I'm using the same shape that's the same size for all the different atoms, but just keep in mind, as we create these circles to represent atoms of different elements, atoms are different sizes. Different elements have different sizes, so it's not realistic, but it's kind of the easiest way to approach this for the modeling of our main goal. Next, take another piece of construction paper of a different color, but this time only trace out 1 circle. Cut that 1 circle out and label it with the letter F. In this case, F is going to represent the fluorine atom. And as mentioned earlier, feel free to label both sides of all the different parts that we're making, unless you're just going to focus on one side being the right side up. Then, using another piece of construction paper, but don't worry, this is your last circle, you're going to trace out 1 circle, cut it out, and this time label that one C, and C is representing a carbon atom. On the final sheet of construction paper of the last color, I want you to make a zigzag line, and then turn that into basically a bolt. I don't know if that makes sense, but you see what it looks like. Kind of like a bubble of the diagonal line, making it into a shape. And you're going to cut that out, and then you're going to label that UV, and that's going to stand for UV radiation from the sun. Now that we have all our supplies, we're finally ready to get started. So to begin, please take 2 atoms of oxygen, and I want you to arrange them together. What is this? This is molecular oxygen. This is oxygen gas. Next, take a single oxygen atom and add it to the molecular oxygen. What does it make? If you said O3 or ozone, you're absolutely right. Now, starting with your ozone, add the UV radiation to it and think to yourself, what might happen to ozone if UV strikes it in the atmosphere? And I'm talking just normal, the sun is shining. What we've been demonstrating is ozone can form, but now we're showing that ozone can break, all natural in the environment, before we get into man-made destruction of ozone. So basically, when UV strikes, and we're talking probably more like UVB or UVC, which are both strong enough to do this, the ozone can be stripped of one of its oxygen atoms. And later on we'll see actually oxygen gas, the O2, molecular oxygen, it can also be split by UV radiation into 2 separate atoms as well. But for right now, let's just visualize O3 separating into O2 and O, and then I want you to try to put them back together to see how this can be cyclic, where O2 and a singular oxygen atom can form back into ozone. So hopefully you can see this idea of O2 and O can form ozone, but then it can cycle with UV radiation breaking it down. But again, it can repeat to be rebuilt. But what we want to switch now is to just focusing on the ozone molecule, how it can be broken down by a man-made chemical. So when the Montreal Protocol was passed and countries said, hey, we need to stop producing something called CFCs, this is what we want to focus on now. So the last thing we had done, we had formed ozone. So make sure that's off to the side. You're going to be using that in a moment. But at your workspace, I now want you to form a chlorofluorocarbon. Now, what you need to know is there's different chlorofluorocarbons. The one we're making is a very simple molecule that is basically Freon 11 or a CFC 11, and it is just made up of a carbon, 3 chlorines, and a fluorine. It used to be a really common refrigerant, so it helped cool refrigerators, air conditioners, stuff like that. Also, it was like an aerosol propellant. I know there were some other functions as well, but bottom line is what they found out is it also depletes the ozone. So let's take a look at how that would happen. So the first step would be UV radiation would strike the CFC. So I want you to bring back your UV radiation and show it hitting the CFC molecule and then breaking away one of the chlorine atoms. And when it breaks away, I want you to move it over to your ozone molecule to visualize how the chlorine will go and attach itself to ozone, but it actually won't just stay to ozone. It's going to steal away one atom of oxygen. This will leave behind oxygen gas or molecular oxygen and this newly formed chlorine monoxide. And obviously, the biggest issue here is ozone has just been destroyed. So we used to have O3, we don't have it anymore, and we are referencing ozone as part of the ozone layer up in the stratosphere. So I just want to make sure we're clear on that because there's stratospheric ozone, which is the layer that protects our planet from UV radiation, and that's what this simulation is discussing. We're not really talking about ozone that's in the troposphere, which, I mean, it is still O3, but that ozone near us, good up high, bad nearby. The bad nearby is because it's a component of smog. It can be it can create respiratory issues for people. So we are not talking about ozone near us. We are talking about ozone up in the stratosphere. But the situation gets worse yet. So what I want you to do next is looking at your molecular oxygen, your O2. I want you to take the UV radiation and bring it over to the O2 to visualize how it can just naturally happen where sun's UV radiation splits up O2 and breaks apart that molecule into 2 atoms of oxygen. Well, why do we care about that? Well, here's the situation. The chlorine monoxide, that after ozone was split apart by the chlorine, it can actually have an oxygen that's a free oxygen atom in the atmosphere go attach to it and steal away the oxygen of the chlorine monoxide, which might not seem like a big deal because obviously there's nothing wrong with O2. I mean, it's the gas we breathe in. We love it. But what are we left behind with? A chlorine atom that's free to go do its destruction again and again and again. In fact, they believe just one chlorine can destroy up to 100,000 ozone molecules before it eventually does leave the stratosphere. But this also explains why stopping producing and using CFCs in so many countries didn't create an overnight fix of ozone depletion. I mean, obviously, this is an environmental success story in the sense that we've identified the problem and we are working on it. But this scenario with the over and over and over again, that one chlorine from one CFC can break ozones, that explains it all. I hope this exercise was helpful, and if you are a teacher, you might want to consider making a class set, laminating the pieces, keeping bags for students to use at their desk, and then you don't have to have the students make them year after year.
Construction paper biology. Like, share, subscribe, won't you please? Thanks!